All right, so now we turn to the last of the terrestrial worlds. Excuse me. So the size of Mars is about half the size of Earth, but its mass is much smaller. It's only about 1/10 the mass of Earth. Um, and it turns out, even though Venus, of course, we just talked about Venus, is essentially the Earth's twin in mass and size, a little bit smaller in both areas. Mars is actually closer to the Earth than the other terrestrial worlds. Remember, Venus is just this horrible, really hot place. 900 degrees Fahrenheit if you measured it in Fahrenheit on the surface because of the greenhouse effect. Um, all right, now Mars is colder on average, but it's something that humans could actually, well, some of it humans could tolerate. All right, anyhow, Mars has been photographed by multiple missions, starting even, I think it was back in the 60s or in the 1970s. There were the Mariner missions. These were just spacecraft that NASA sent out. Excuse me. That just were flybys. They basically went by the planet and took pictures. Surprisingly, we got a lot of information, even with those quick flybys. The Viking mission there were actually two spacecraft. They Viking 1 and Viking 2. They landed on different places on Mars. And they were actually like giant, well, not giant, but they were laboratories. They had the very bold idea of proving that there was life on Mars. Nowadays, we're still trying to prove that they were actually looking for active living things on Mars. Now we've backed off of that idea because, of course, the Viking missions proved that there wasn't any. At least in those two areas, there wasn't any life on Mars. But now, what we tend to do with the rovers and things like that, the rovers and other missions since the Viking 1976, the bicentennial of the United States, is to prove that life once existed on Mars, and probably if it did, it was microbial life. Just really tiny things. All right, this is another spacecraft, the Mars Reconnaissance Orbiter. As its name implies, it just goes around Mars over and over and over again, taking lots and lots of pictures. There are always nowadays there are always various spacecraft that are in orbit around Mars, and that's actually to communicate with the rovers on the ground, and then relay the information to Earth, and then relay the instructions from Earth to the rovers. All right. So anyhow, that's all right. So on a very warm day, so an exceptionally warm day, it is um, it is about. So let's use Fahrenheit because in the United States we're more used to this. Um, it's 50 degrees Fahrenheit, right? So that's a very warm day. Now, if you think about it, right? I mean, humans can survive at 50-degree Fahrenheit. I mean, we do all the time. You probably want to wear a jacket or something like that. Of course, Mars is its atmosphere would not support life. Not our life anyway. Surprisingly, even though Mars has a very thin atmosphere, and we'll talk about how thin a little bit later, there are huge winds that sweep across Mars, and you can actually see huge dust clouds sometimes. This surface feature is not a dust cloud, by the way. You can see these large dust clouds on Mars. And sometimes they're so bad that they will. prevent us from actually seeing the surface of Mars. Excuse me. See the surface of Mars. This is a feature that even with a small telescope you can easily see. This is the south pole. So the poles, both poles, the North Pole and the South Pole, have ice caps, and it's very easy to see that with a small telescope. It's distinctly white compared to the orange, the reddish orange. I should say red because everybody talks about that Mars is a red planet. I mean, it basically looks kind of dark orange, I would say. And by the way, the reason that Mars is orange is the same reason that rust is orange, right? So there's a lot of iron in the rocks that make up the surface of Mars, and that iron has rusted. Not exactly the same chemistry like on Earth, because of course Earth has lots of oxygen for the rust to take place. This is a slightly different, but it's basically it amounts to the same thing. The rust is an orange color, and that's the way the overall look of Mars is. The polar ice caps are frozen carbon dioxide, also known as dry ice. You can buy that in the grocery store. You go to the some grocery store, and there's always like a very special, well, not very special, but a special freezer that they store the dry ice in. It's frozen carbon dioxide. That's all that is. And there's also water ice on that covers up I'm sorry, the water ice is underneath, and the frozen carbon dioxide covers it up. All right. This is a feature on Mars. One of the first features that we want to talk about, called the Tharsis Bulge. This is a region where some kind of geological activity took place on Mars, and the mantle rose up and lifted the crust really, really high into the air, and in fact, the highest point so there's mountains with this Tharsis Bulge, and the largest part is the peak of it is called, or the mountain itself is called Olympus Mons, and it's huge. It is by far the largest volcano in the entire solar system. The largest mountain in the entire solar system, right? I mean, the distinction between mountains and volcanoes is tenuous at best. All right, so anyhow, it's at least 3 times the height of Mount Everest. There's a slide that we're going to see a little bit later, and it will show us that. So we believed to be formed from material in the deep, within the mantle of Mars, pushing up on the crust. We don't see a lot of impact craters in this particular area, and so we think that the age of this is somewhere less than 250 million years. Nearby, there is another feature on Mars called Valles Marineris. All right, so Valles Marineris, which by the way, was named after the Mariner spacecraft that first detected it. But the Valles Marineris is gigantic. Like it's so much bigger than think about the Grand Canyon, right? The Grand Canyon takes up part of the northern part of the state of Arizona, right? I mean, if you've never been to the Grand Canyon, by the way, I strongly recommend it. It's a breathtaking experience just to be near this incredible canyon that was created by the forces of the earth. Now, the Valles Marineris is a canyon on Mars that stretches basically the size of the continental United States. So like 4,000 kilometers long. It's more than 100 kilometers wide and 7 kilometers deep. So this is gigantic, and we think that it might like it arose around this, well, not arose, but it formed around the same time that Olympus Mons formed. And the reason that these two features in particular, Olympus Mons and Valles Marineris, are so large is because the gravity on Mars is so small. It's about roughly 1/4 the gravitation on the Earth. So that's something to be aware of. All right, so here is Olympus Mons. But by the way, the largest mountain on Earth is actually Mauna Kea. It's not the highest peak, but the size of the mountain from the base of the mountain, which happens to be underwater, underneath the ocean, to the top is about we'll use miles here just because it's just easier to talk about. 6.3 miles, whereas Mount Everest is about 5.5 miles in height. Right, so Mauna Kea is its elevation is lower at the top, but that's just because a good fraction of it is underneath the ocean. All right, so now Olympus Mons is much higher. So it's more than 15 miles from the base to the top of the mountain, or the top of the volcano. So more than 3 times the height of Mount Everest. Let's see. So this is the southern polar ice cap. So Mars is actually tilted right now, and there's a reason that I'm saying right now, because Mars tilt actually will change over the course of millions of years. We'll get to that in just a little bit. But right now, Mars is tilted by about 25 degrees. Remember, the Earth is tilted by 23.5 degrees. So the thin atmosphere creates a more severe extreme season, which leads to large ice caps. All right, so the southern ice cap is in the winter time it's 5,000 kilometers across. In the summer, it shrinks to about 350 kilometers. All right. The other thing that I should mention is the ice caps don't melt per se. What happens is they undergo what's called sublimation, which is turning directly from a solid ice to a gas. And remember, these are water ice covered with carbon dioxide, frozen carbon dioxide. And so the frozen carbon dioxide and the water ice sublimate and become part of the atmosphere. In the northern hemisphere, you don't get as an extreme of extreme difference between the winter and the summer. So in the summer, the polar cap is about 3,000 kilometers, and what did I say? I think I meant the winter. In the winter, I don't know what I said. In the winter, it's 3,000 kilometers. And then in the summer, it'll shrink to about 1,000 kilometers. And of course, it's sublimating the frozen carbon dioxide, going directly from ice into the atmosphere, into gas. The caps are covered by water ice as well, and dry ice. So here's an interesting thing that some scientists did, is if you looked at all the water on Mars, right? So the frozen water, because it just seems to be frozen water, if you were to turn that into a liquid, the entire surface of Mars would be covered in about 10 meters of water, right? The entire surface. So every time this sublimation, about 15% of Mars's atmosphere goes up into the atmosphere.